This is pre-algebra lesson 5-9, powers of products and quotients. You can use the commutative and distributive properties to find a pattern in products raised to a power. For example, 4 times 2, that product raised to the third power, means 4 times 2 times 4 times 2 times 4 times 2. Or, if you want to simplify it, 4 times 4 times 4 times 2 times 2 times 2. Or 4 to the third times 2 to the third. This result suggests a rule for simplifying products raised to a power. Remember, we have rules for a power multiplied by a power. We have rules for a power divided by a power. Now we have a rule for raising a power to a power. The rule for raising a power to a power says that to raise a product to a power, raise each factor to that power. For example, 5 times 3, all raised to the 4th power, means to distribute that 4th power to both the 5 and the 3, and make it 5 to the 4th times 3 to the 4th. Algebraically, AB raised to the mth power is A to the m, B to the m, for any positive integer n. So, how do we use this? Okay. To simplify expressions, you should eliminate as many parentheses as possible. So if I have 3z to the 5th, all raised to the 4th power, that means I need to distribute this 4 throughout my 3 and my z to the 5th, because both of those are in the parentheses. So this becomes 3 to the 4th, z to the 5 times 4, because remember a power raised to a power is multiplied. So this becomes 3 to the 4th, z to the 20th. Okay? And 3 to the 4th happens to be, 3 times 3 is 9, and 9 times 9 is 81, so it would be 81 z to the 20th. If I have the product of 3 inside the product of 2, all raised to the 3rd, okay, since everything inside the parentheses is raised to the 3rd power, that 3 gets distributed to the 2 and to the 3, so it becomes 2 to the 3rd times 3 to the 3rd. Okay. 2 to the 3rd is 8, 3 to the 3rd is 27, and 8 times 27 is 216. 2p, quantity to the 4th, means 2 to the 4th, p to the 4th, 2 to the 4th, p to the 4th. 2 to the 4th is 16, so it becomes 16 p to the 4th. Xy squared to the 5th becomes x to the 5th, y squared to the 5th, so x to the 5th, y to the 2 times 5, for the power raised to a power is multiplied, so x to the 5th, y to the 10th. And our last example here, 5x to the 3rd, all raised to the 2nd power, becomes 5 to the 2nd. X to the 3rd, raised to the 2nd, becomes x to the 3 times 2. So it becomes 5 squared, which is 25, x to the 6th power. Now, the position of the negative sign when working with exponents is critical. I think I've said this before. So pay really close attention to where that negative sign is, because the difference between 1 here and problem 2 is highly significant. The first problem says the product of negative 5x, when you take that whole product and square it. The second problem says take 5x, square it, and then take the opposite of it. It says the opposite of 5x quantity squared. So in this first one, we have negative 5 squared, and that has to be in parentheses, x squared. So negative 5 times negative 5 ends up to be positive 25x squared. In problem number 2, we have the opposite of 5 squared, x squared. So 5 squared is 25, x squared is x squared, but the opposite of that becomes negative 25x squared. Notice the difference between the two problems. That's a huge difference, and we need to make sure we pay attention to that. If the negative sign is within the parentheses, then the exponent has to be applied to that negative sign as well. If the negative sign is not in the parentheses, the exponent does not need to be applied to that negative sign. Let's look at problem number 3. We have negative 5a squared b quantity cubed. So that becomes negative 5 in parentheses to the third power, a to the 2 times 3 power, b to the third power. So negative 5 to the third. 5 times 5, negative 5 times negative 5 is positive 25. Positive 25 times negative 5 is negative 125, because this is what this is saying. So we have negative 125, a to the 6th, b to the third. Okay, let's look at something else. Now, we can use repeated multiplication to write the power of a quotient. Say we have the quotient of 4/5, and we're going to raise that to the third power. That truly means 4/5 times 4/5 times 4/5. Or 4 times 4 times 5, 4, all over 5 times 5 times 5, or 4 to the third over 5 to the third. Which means when you raise a quotient to a power, you have to distribute that power to both the numerator and the denominator. So distribute that power to raise both the numerator and the denominator to that power. I'll show you what these are arithmetically. Okay, or with arithmetic, 2/3 to the 4th power becomes 2 to the 4th over 3 to the 4th. AB to the m power becomes ABM over B to the m. So let's practice some of these types of problems. Okay. So if I have negative 2y to the 4th, again that negative is in the parenthesis, so we have to keep it in the parenthesis when we take it to the 4th power, so that becomes negative 2 to the 4th, y to the 4th. Negative 2 to the 4th is going to be positive 16, y to the 4th. Okay. The second problem here says the opposite of 2y to the 4th. So I have 2 to the 4th, y to the 4th, and then I take the opposite of that, so that becomes negative 16 y to the 4th. Big change in where that negative sign ends up. Really only changes when you take it to an even numbered power, but that's still very critical. If I have 1/3 raised to the third power, that becomes 1 to the third over 3 to the third. 1 to the third power is 1, and 3 to the third power is 27, so this becomes 127. If I have negative 2/3 all to the 4th power, remember this fraction is negative, either the numerator is negative or the denominator is negative, so let's just keep it on one of the fractions or the other. Let's not put it on both because that would mess it up. So I'm going to make it on the numerator, so negative 2 to the 4th power over 3 to the 4th power. Negative 2 to the 4th power is going to be 16, and 3 to the 4th power is 81. So we end up with positive 1681st because a negative 2 raised to the 4th power means I'm going to have 4 negative signs, which makes it positive. And then we have 2x squared over 3 all raised to the 3rd power, which means I'm going to have 2 to the 3rd power, x to the 2 times 3 power over 3 to the 3rd power. 2 to the 3rd power is 8, x to the 2 times 3 is 6, 3 to the 3rd power is 27, so 8x to the 6th over 27. Last but not least, find the area of a square with side length of x over 4. Well, if you remember, the area of the square is area equals the side squared. So if the length of the side is x over 4, and we're going to square that, we get x to the second over 4 to the second, which becomes x to the second is x squared. 4 to the second is 16, so we have x squared over 16. And that is powers of products and quotients. So you've done powers to powers, dividing powers, now you've taken raising a product to a power, and now you've raised a quotient to a power.